So the purpose of this video is to walk you guys through how to solve one-step equations. It does require us to remember some of our integer rules and what our inverse operations are. So just so that you guys have this down, the four inverse operations that we're going to look at are add and subtract. Okay, so those are inverses of each other. And then multiply and divide. Okay, so those are going to be important as we move forward. For two of the problems, I'll also be showing visual ways for you to represent the problems that are being shown. So the first one, we're going to look at something somewhat easy. If we start with x plus 4 equals 9, and if I were to represent that in a tape diagram, okay, my equation has two terms, and so I would split this into two pieces, one being the x, our unknown, and one being the 4, the part that we do know. And our box as a total, our equation as a total, is 9. So for those of you that have me in class, you might recognize this. For those of you that are just tuning in, if you've never seen this before, it's just a visual way to represent an equation. So I want to show it in the tape diagram first and then kind of show how it works mathematically through our algebraic algorithm. So if we know that this whole box is 9, okay, the whole thing, and we know that this portion is 4, and I only want to know this section, okay, if the whole thing's 9 and this piece is 4 and I just want to know part of it, I would do 9 minus 4 to figure out the remainder of the box, which gives us 5. Now, I realize this was an easy problem. I'm kind of using something easy on purpose. So if we're looking over here, we know that an equation has two sides and it's split by that equal sign. The whole reason it's even called an equation is because it has that equal sign. And we know that whatever we do to one side, we must do to the other in order to keep it equal. So if we put 5 apples on this side, we got to put 5 apples on this side. If we put 3 oranges over here, we got to put 3 oranges over here. In this case, though, we are looking at a very particular problem where it says x, our unknown, is having 4 added to it. And I want to get x by itself. So the opposite of adding 4, using our inverse operation, would be to subtract 4. But right now, my equation is lopsided. I've done it here, but I haven't yet done it here. Okay, and negative 4 is actually equal to negative 4. So we have positive 4 and negative 4. Those are considered a zero pair, meaning if you were to combine them together, they actually cancel each other out. And what you're left with on this side is x by itself, which is the goal. Okay, we're trying to isolate that variable. And over here we have 9 minus 4, and that gets us an answer of 5. So we do end up with the same answer. And if you look, the math was actually exactly the same. We just went about it in two kind of different ways. All right, so I'm going to look at a subtraction problem. This one I will not be showing visually. So if I have y minus 3 equals 12, okay, we know that we're going to draw that line at our equal sign because it splits our equation into our two halves, our problem and our answer. And y is having 3 taken away from it. So in order to undo that, I would add 3. And if I add 3 over here, I need to add it on this side. Okay, because again, we want to keep each of our lines equal. Now, we have minus 3 here and positive 3 here. Those again are considered a zero pair because negative 3 plus 3 would be 0, or 3 minus 3 would be 0. So those cancel out and go away. And all we are left with on this side is y. And over here we have 12 plus 3, which gets us 15. Okay, the next problem that I'm going to show you guys is multiplication. So if we have a problem like okay, 4x equals 32, I can show that in my tape diagram. Okay, we only have one term over here, but it is split into 4 pieces. So I have 4 x's for a total of 32. So if we know the total is 32 and it needs to be split into these 4 equal x's, I would do 32 divided by 4 to get me 8. Okay, and if you go back and check that and you do 8 plus 8 plus 8 plus 8, you should get the total of 32. So coming back over here, I want to show that using my algebra. So same as before, even though it's multiplication, now I want to draw that line. We have 4 times x, and if we go back up to the top and we look at our inverse operations, we were using multiplication, so the inverse of that is going to be to divide. Okay, and I know over here I showed us using division with our old division symbol, but we're going to use it as though we are looking at a fraction. And if I am dividing by 4 on this side, I need to divide by 4 on the other. Now, this is a little different than what we showed up here, because this creates a 0 pair. Down here, we are not creating a 0 pair. Rather, what we're doing is getting our x value, the number in front of x, to be 1. And 4 divided by 4 does leave us with 1x. You don't have to write this, you can just leave it like x. And on this side, we would have 32 divided by 4, which would be 8. Okay, these two are equivalent to each other. This one just has the 1 in front of it. Okay. The last type of problem is when we're looking at division. So if you had y, use a different variable since it crosses underneath of the line. Let's say we had v over 3 is equal to 5. So what this is saying is whatever this v is, whatever this number is, we're dividing it into 3 pieces and it's equal to 5. And if we again go back up to our inverse operations, we're using division. So the inverse of that is multiplication. So if v is being divided by 3 and I want to undo that, okay, I need to show that I'm multiplying by 3. I put this in parentheses because we've got a fraction here. So if I'm multiplying by 3, it's really 3 over 1. Because if I'm multiplying a fraction by a whole number, we've always got to make that whole number into a fraction. And if I'm multiplying by 3 over here, I need to multiply by 3 on the other side. This is usually the most complicated one, but when you kind of say it out loud in your head, it makes a little more sense knowing whatever number is up here is being divided into 3 parts, and each of those parts is 5. We know what it needs to be a pretty big number. So again, we have 3 over 3, and we are going to be left with 1v on this side. And on the other side, we have 5 times 3, which gets us 15. And if we were to think about that, 15 over 3 would in fact simplify to get us 5. Okay, so that's just a quick way to check our answer.